Welcome back to Maths with Mrs. J. Today I wanted to do something a little bit different. I want to go through a challenge question with you. Now, the reason why this is a challenge question is that we're asked to solve simultaneously two equations that are very definitely not linear, and they're not even quadratic either. In about probably year 10 at school, you learn how to solve two simultaneous linear equations, either using elimination, which means that you're getting rid of either the x or y by adding or subtracting the equations and then substituting back in, or by writing x in terms of y or y in terms of x and then substituting in to work out the answer. Substitution can also be used if you have one linear equation and a non-linear equation, because the linear equation you can rearrange and then sub into the non-linear one. What we're dealing with here, though, is very definitely non-linear. It's not even quadratic. Definitely, when you're looking at this, you've got to think through your toolkit of things that you've got available to solve. Now, elimination is not going to work because no matter what I do to both equations, let's call this one equation 1, that's equation 1 and that's equation 2. No matter what I multiply each equation by and then subtract them or add them, I'm not going to be able to eliminate any of these because I've got an x cubed term. Let's just write this up here, what terms we're dealing with. We've got an x cubed term. We've got an x squared y term. We've got an xy squared term, and we've got a y cubed term. None of those are the same. They're not like terms, so we're not going to be able to use elimination. So that's off the table. All right. Substitution, again, that's going to be really fiddly given the situation here. To try and get x in terms of y or y in terms of x is going to be a bit of a mess. It is doable, but it's probably not the best way to proceed. Then I thought about maybe I could just straight out subtract these, and then I've got an x cubed minus y cubed, and then I've got two more terms subtracting. I could factorise the x cubed minus y cubed, which gives you x minus y, x squared plus xy plus y squared, but then you're not going to get the correct thing happening here either. So then I had another look back at this situation and I said, I've got an x cubed term, an x squared y term, an xy squared term, and a y cubed term. Not all in the one equation, of course, but they're all the terms I'm dealing with. What does that make me think of? Well, may or may not recall that x plus y all cubed is x cubed plus 3x squared y plus 3xy squared plus y cubed. That's the a cubic expansion, either using the binomial formula or just knowing that off by heart. Now, if I were to add these two equations together, I'm not going to get exactly that, but I'm going to get something kind of like that. So maybe we can work with that. Let's have a think about this for a minute. We've got a 3 here, and what we really want is a 9. What if instead of y, so instead of y here, 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 and here, how about I try a 3y? Let's see if that would work. So x plus, let's do our 3y all cubed. So what would that give us? Well, it'll give us our x cubed plus 3 times x squared times 3y. That gives us our 9. Oh, that's looking promising. Okay. Then we're going to get 3 times x times 3y all squared. 3y all squared is 9y squared. 3 times 9y squared is 27y squared. So 27xy squared and 3y all cubed is 27y cubed. That's looking a little bit more helpful now, isn't it? The first two terms are exactly what we've got in equation 1. The second two terms, well, we're allowed to multiply an equation by a constant. How about we do that? So let's do equation 2 times 27. So we're going to get 27y cubed plus 27xy squared is 54. We'll call that equation 3. So if we now add this equation to this equation, so add 1 and 3, we're going to get, I'm going to write it in the order that it is here. We're going to get our x cubed plus our 9x squared y plus our 27xy squared plus 27y cubed is going to be 10 plus 54, which is 64. Cool. All right. Now we know that this is x plus 3y all cubed. We know that because we've expanded it out there and we've checked. So if x plus 3y all cubed is 64, then x plus 3y is the cubed root of 64, which is 4. Let's call that maybe equation. Oh, well, let's just fiddle with this for a minute. So we'll call this equation 4. So x is going to be 4 minus 3y. Call this equation 4. All right. So what are we going to do? So now we are going to solve. We're going to substitute back into this equation here, not the one with the 27 times it, just sub it into 2. So y cubed plus 4 minus 3y times y squared is 2. So all I've done here is I've subbed x is 4 minus 3y in place of x. All right, what are we going to do now? We'll obviously expand. So y cubed plus 4y squared minus 3y cubed is 2. So negative 2y cubed plus 4y squared, bring this over, minus 2 is 0. I'm going to divide the whole lot by negative 2. And we're going to move up to here and we're going to get y cubed minus 2y squared plus 1 is 0. All right, so we're now at a crucial stage. Hopefully I haven't lost too many people along the way. Now this is like, I have done a video about the factor theorem, which is a special case of the remainder theorem. We're looking for a factor of this that we can then divide by and then help us solve the rest of it. If y is 1, and you sub it into here, it does work. 1 cubed minus 2 times 1 squared plus 1 is 0. So y equals 1 is a solution. So y minus 1 is a factor. All right, that's from your factor theorem. All right, let's do the division. Let's do the long division. So remember when I've done these ones before, if there's a missing term, just to make sure we don't mess up, I always put it as a 0 at this stage. So we're dividing that by y minus 1. Leading term divided by leading term. Y cubed divided by y is y squared. Y squared times y is y cubed. Y squared times negative 1 is negative y squared. Take our subtraction. They go. Negative 2y squared minus negative y squared is minus y squared. Bring down your 0y. Negative y squared divided by y is minus y. Minus y times y is minus y squared. Minus y times minus 1 is plus 1y. Subtracting and bringing this down. Dividing, we get minus 1 and we get this. And of course, we should get a 0 there because we already knew that y minus 1 was a factor. Okie dokie. So let's continue. I'm going to need to open up a new screen here. So bear with me. And we will do that. Okay, so we've got to the point where we've now got, what did we have? We had we had y cubed minus 2y squared plus 1 was 0. We said y minus 1 was a factor. And we did our division and we got that this is the same as y minus 1 times y squared, what was it, minus y minus 1. All right, so now we're going to put that equal to 0. So y minus 1 is obviously, y equals 1 is obviously a solution. So y equals 1 is a solution. All right, what about solving this? All right, the discriminant of this, b squared minus 4ac, is going to be 5. So we're not going to be able to get rational solutions. We're not going to be able to factorise this. So we're going to use our quadratic formula. So using our quadratic formula gives us that y is 1 plus or minus square root 5 on 2. I've left out a little bit of working there. That is correct, isn't it? Yeah, 1 plus or minus root 5 on 2. Then all we really need to do is for each of these 3 y values, sub back in. Remember we had an equation that we said that x was 4 minus 3y, and I think we called that equation 4. So we're going to sub back in to find out the relevant x value for each y value. So when y is 1, this one's nice and easy. X is 4 minus 3 times 1, which is 1. So one solution is 1, 1. All right. When y is 1 plus root 5 on 2, x is going to be 4 minus 3 times 1 plus root 5 on 2, which is 8 minus 3 root 5 on 2, which is 5 minus 3 root 5 on 2. So this is our second solution, is going to be 1 plus root 5 on 2, 5 minus 3 root 5 on 2. And finally, when y is our 1 minus root 5 on 2, x is going to be 4 minus 3 times this, which is all over to 8 minus 3 plus 3 root 5, which gives you 5 plus 3 root 5 on 2. So the third solution is your 1 minus root 5 on 2, 5 plus 3 root 5 on 2. And so I would then go back and just underline the 3 solutions, and Bob's your uncle.